Excellent. Greetings, everyone. Thanks so much for joining us for this first in a new series of Performance IQ webinars and reports. We're diving deep into network performance and gamer experience, and in particular, looking at market leaders across key global markets. Today, as you know, we'll be looking at the UK. I'm Michael Baylor, I'm the CMO of GameBench. I'll be hosting and moderating this event for you. Now, for those of you who are new to us, I'll give the very briefest possible intro to get us right into the conversation as soon as possible. And for more background, do check our website, which is at gamebench.net. So, GameBench is a pioneer and a world leader in game performance management. We have unique expertise in the scientific measurement and optimization of all experience technologies across every form of rich media. We launched in 2013 to support gaming in meeting the unprecedented performance challenges, well known to everyone on this call, of course, of the Android explosion. And as we all know, mobile gaming has since grown to make up 50% of the industry's close to $200 billion of annual revenues. So GameBench today serves two complementary markets. We provide performance analysis, benchmarking, and monitoring services worldwide to ISPs, to mobile operators, and also to device manufacturers. And we deliver performance testing and monitoring software and services to leading game developers and publishers. As you can see from the chart, which I'm sure you can see clearly, having anticipated and responded and continuing to do so to gaming's continuous waves of disruption, has won us good market-leading clients across the entire ecosystem. Right, that's the corporate bit over and done with. My colleague Karthik Haraharikrishnan, the GameBench co-founder and CTO, is going to be leading today's presentation with support from me, and also in the background, the invaluable Adele Tibier. Before I hand over to Kay, a couple of points about how we're running today's session. You'll hopefully have plenty of questions.
Michael, sorry to interrupt. Can you speak up a little bit, Michael?
Yeah, sorry, is that better?
Yeah, slightly better, yeah. If you just come a little closer.
Oh, okay, sure. Sorry about that. I hope I don't have to start again. You'll have plenty of questions, and we'll be aiming to respond to them as we go along. Please put them into the chat as soon as you like, and we'll bring you live into the discussion to discuss them with Karthik. So be ready to become an instant panelist here. We'll be wrapping promptly on the hour, of course, and if you don't get a chance to discuss your question with us here, please do contact us after we close. We'd love to hear from you. Right, that's quite enough from me. Kay, over to you.
All right, thanks, Michael. As Michael said, I'm Karthik. I'm one of the founders and currently look after all tech and product within the company. Very keen, very excited to have this series of webinars. We'll be kickstarting this today. All right, let's dive straight to the meat. Okay, so we're going to first discuss what are the key performance metrics that are important for the gamer standpoint. As a company, one of the things that's central to what we do is to understand gaming from the gamer standpoint, and what are the metrics that a gamer cares about that captures user experience for a particular gaming session. So for this webinar and the sequence of webinars, what we're going to be looking at is network-centric gaming. And when we say network-centric gaming, what we typically mean is typically falls into two sides. On the one side, you've got your games that are massively online and which need a network component for you to compete or play. On the other side, you've got cloud gaming, where the whole game is actually rendered on the cloud. So the key metrics across both of these are slightly different. I'm really sorry. Looks like my Siri is popping up at an inopportune time. So yeah, just getting back. So we've got on the native gaming, if you were to look at what are the key metrics that one needs to track, it's what we call round trip time to the gaming server. And this is slightly different to what people call as ping. You ideally want to know what the game sees as the round trip time to the server and back. Then some of the other metrics are packet loss and jitter. You want to ensure that all your packets, your positional packets and everything else that you're sending to the game server are received in time. Another thing that's important is what is the spec of the machine you're using locally. It's the higher the spec, the better the frame rate usually. And server tick rate. Server tick rate is something we'll go into a little bit more detail in the next slide, but this is how fast the game server is operating. On the cloud gaming side, the equivalent metrics that gamers care about are, one of the key metrics is end-to-end latency. So when we say end-to-end latency, that's what we call as input latency. We call it input lag. Gamers call it input lag. That's one of the key metrics that we need to track to ensure that the gamer is getting a consistent experience while gaming, because the rendering is happening in the cloud. The other two aspects which are also equally important are the encoded video frame rate. You want to know that the frame rate that you're getting is as high as possible, and the encoded video resolution as well. You want a good quality video stream. So with the cloud gaming operators are now going up to 4K. You want to actually see and feel as if you're playing natively. So those are the aspects that we need to look and think about when we want to understand these gaming experiences from a gamer standpoint. Going into a little bit detail on the native gaming side, bear in mind we're going to be running a webinar specifically for native gaming in a later point in time. But some of the aspects that will affect your online gaming experience are what's listed here. The first thing is what we call as slow-mo servers. So typically when a game sends its input across to the game server, what generally happens is the game server runs what's called a simulation. And the simulation it takes all the gamers who've sent their inputs, runs a simulation, and it sends the actual positions of the 3D world back to each of these individual players. Now it's likely that if when running that simulation, it goes over a predefined amount of time, it looks like the server is not able to respond to your inputs. So that is a cause of lag when you're doing your native games. The other thing you have to look at is what is the tick rate that the game is using. So this is highly dependent on the game. For instance, if you were to play Apex Legends, the server would do 20 simulations per second, whereas Valorant is 63. CSGO is quite quick as well. So in general, you want the server tick rate to be higher. The higher, the better. But there is a lot of pros and cons. There is a very good blog by an Apex developer, which I've linked down below, which goes into a great detail onto why server tick rate is probably not just the deciding factor. Then the usual issues with respect to Wi-Fi that I'm sure everybody here would probably know about. You might want to change your channels. You might want to move closer to the router, make sure you're using the same, using 5 gigahertz if possible. And I've also seen, when I was looking at this particular issue, that there are gaming routers, and I was astonished at the amount they charge, upwards of hundreds of quids. Maybe that's another thing that you could try to improve your gaming performance as well. One thing that can also affect is peering issues. Peering is a concept on the right-hand side, as you can see, if you want your traffic to flow from one part of your, from your game machine to your game server, it goes through a lot of hoops. And peering are arrangements where two different networks have an arrangement between them where the traffic flows between one to another seamlessly without taking another route. So it's likely that, in some cases, we've seen that these links are not established. These links are established for certain operators, but for not established for other operators. And as a result, they would see higher latency because of non-existent peering arrangements. So that is something that can also affect your packet loss and the end gaming experience that you can get. Moving on, the key topic of this webinar is cloud gaming. And the first metric that I mentioned was input latency. I don't know if you guys can see if you can all see the animation on the right side at a decent frame rate. But basically what we need to measure is from the time that somebody triggers the gun, what is the time between that to the gun flash, the first frame that's holding the gun flash. That's a very good, and that's the metric that users care about. Users want to have an experience where that input to muzzle flash, as we call, remains consistent over a gaming session. You don't want it to be high. If it's very high on an average, it is, you tend to feel as though your input is not being acted upon immediately. That is still okay, but if the latency varies, let's say between 100 milliseconds and 250 milliseconds, then that latency is perceived as really bad from a gaming standpoint. The second aspect is video frame rate. There's a nuance here that I'd like to highlight. There is what we call an encoded frame rate, and there's what is called the observed frame rate. In the case of the encoded frame rate, it's what the game server is sending us. Could be a 60 hertz, 60 frames per second, but it's likely that the client would receive 60 frames per second, but unable to decode all 60 before displaying it. So that can also affect what you see, because if you drop a couple of frames, your latency increases. The last aspect is resolution. Now, resolution, when it comes to the cloud gaming providers, is generally platform dependent. GFN is GeForce Now. GeForce Now takes a different stance as opposed to xCloud, as opposed to Stadia. That some of them want to keep your frame rate the same, and then they want to vary the quality in case your network throttles or if there are issues with the network, whereas some of the others, hold on a constant resolution. So you can see that especially when you're gaming on Wi-Fi versus like 5G, where they drop the resolution instantaneously. So those are the networks that those are the metrics that we care about for cloud gaming.
Hey, before we go on, can I just pick up
a
question from Dragos Florentine? Raised the point that there might have been an inaccuracy in one of our earlier slides around the Valorant tick rate. I think we had it as 63, and he said that all their servers are 128. I'm not sure if you wanted to pick that up.
Sure. So yeah, I mean, this is something that I was researching on the web, so I might have I got it from a Reddit post. If it is 128, we're happy to discuss again and change it.
Thanks, Kay, that's great. Dragos, hope that covers your point.
All right, should we move on, Michael? Anything else?
Absolutely.
You're on mute.
Absolutely.
All right, cool. Let's move on then. So the second aspect is more interesting. I'm just going to talk about how I've mentioned some of the cloud gaming metrics and what is important for a gaming standpoint. The second aspect that now in this part, we'll discuss about how can we measure some of them, right? So in this first thing I'm going to talk about is input latency. As I said, the definition is input to action, right? So the first thing you can use is what we call a high-speed camera. So in this particular video setup that you can see on the right side, which I'm going to play, you'll notice a instrumented controller. What we have is we've taken a mice on the right-hand side, we've instrumented it. So every time you click, you can actually see an LED pop up. And you take a GoPro or a high-speed camera, obviously look at what when that lights up and count from then on till when the flash actually is rendered. So it's quite a cumbersome process, but it works. And this is what we use as reference, what we use as golden to be able to calibrate some of our internal tooling that I'll show and discuss a little bit about in the later slides. So if I were to moving back, if I were to play the video again, you can see that the image lights up and then obviously the gun flashes. So this is very good to understand ballpark what is your input latency when it comes to different cloud gaming services. The second thing that we've seen is very useful is NVIDIA have a range of equipment called reflex monitors, which can be used especially in conjunction with Windows. It doesn't work for other platforms, but when it works with Windows and when you get a compatible gaming mice, what you can find out is the hardware actually displays what the latency is going to be, although you can't really get the latency value out as a for archival purposes. You have to actually manually write what latencies you're seeing. And the last thing that we've at Gamebench we've come up with is the first solution that we know of, at least, that can instantly measure and report game input lag without any external hardware. So the advantage of using a purely software solution is that we can increase the speed of computing latencies measurements by 200x, whereas compared to the high-speed camera. So if you were able to take 4 or 5 measurements in a minute, we'd be able to take close to 1,000 measurements or more. So quite handy for us. We started with the approach that I was showing you here, and then now we've gone on to a software solution to be able to measure what is a key metric. The second aspect is frame rate. Now, there's a lot of things going on here, but the thing is that the key takeaway from this slide is basically there are different approaches that can help you measure frame rate. For instance, the high-speed camera approach is something that you can use to measure frame rate, but again, very cumbersome. But you would also find the second approach is on-screen overlay. Some of these providers have an option to be able to display what the current streaming frame rates are. On the right-hand side, I don't know whether you can see that this is one of the providers, can't remember, maybe GeForce now. It does mention that what the FPS is that they are sending, and what's being displayed. There is a bunch of other stats that they would provide, but this is very dependent on the vendor, right? So if you want to do this for another vendor, it's likely that you don't have that ability to measure that. And WebRTC is another really good piece of information. So if you were to have a cloud gaming session on the Chrome browser, or I believe it will work on Edge as well, and if they're using what's called WebRTC, which is a standard piece of technology used for streaming video conferences, and it's used for cloud gaming as well. You can go into a tab and then try and understand what it gives you some detailed statistics on which I've shown down below for things like how many frames are received, what is the frame height and width I'm receiving. So it's very cool stats. If you were to have a cloud gaming session that's running on a PC, you would be able to understand a little bit more about what are the frames received, so on and so forth. Then there's some other tools that you can use. Present one being one that we've used internally, and vendor tools as well. So there are GPU profilers from NVIDIA or from AMD that you can use to get what the frame rate is. They might have different aspects to it. The only thing is, again, they would have encoded versus displayed. You have to always keep in mind, what is the user seeing? Is the user seeing what is being sent, as well as video frame rate, or what is actually being displayed? And the last, and we've as part of ProNet, the software solution that I was mentioning earlier, that we've released as part of the company, is we measure frame rate that is actually seen by the user. So what is actually presented, as we call it. So in Windows, there's the concept of what is the GPU rendering at, and what are you actually seeing? That depends on what your display refresh is going to be. So that's what's the most important to the gamer. Moving on, another important topic that we need to tackle is resolution. Now, resolution is probably the hardest metric to measure objectively. Again, we'll have to sometimes we rely on on-screen overlays. On the right-hand side, you can see this is a vendor that's basically telling me that they are streaming at 720p at 60 FPS, and some other bits of information as well. It's very hard to measure consistently across using a generic method. So typically, you'd have to end up using cues from system logs, either go look at what NVIDIA is saying, or Stadia is saying. Yeah, to be able to understand that. WebRTC, as I mentioned from the earlier slide, has some indication on resolution as well. So that you can use to measure what is the resolution I'm seeing for the cloud gaming stream. And lastly, an important thing that is a side effect of a side effect of the network and how it's behaving is blockiness. So you want to understand objectively whether a gaming experience has blockiness. I'm not sure if you can all see on the left hand side we have we captured a video which has a poor connection, and as a result introduced quite a bit of blocky artifacts. On the right hand side you can see the same kind of video that we play, same kind of game we are playing with a good connection. And we have, as part of the tool that's built, the software tool, we can take and assess if there are blocky artifacts. And on the right hand side, you can see in the graph that both the connections, the red one is actually the bad connection, showing that it does have a blockiness artifact. So we, from our side, are trying to quantify how you can, how we can objectively measure blockiness. Some of the other methods I've seen, Stadia has a really good blog that I'd recommend you guys to go and have a read as well. So if you're interested in this particular quality, they call it the perceptual video quality, where they have a machine learning based approach where they've taken a bunch of videos, trained users to give a mean opinion score, and then they predict what the perceptual video quality would be based on machine learning. So we are starting with a slightly different computer vision based approach, but there are areas where we're looking at which will use machine learning for predicting image quality. All right.
Hey, can we grab a quick question? Is my sound better, first of all?
Yeah. Really good.
Perfect. Sorry, we've discovered the problem. My apologies, everybody. I've not come across that problem before, but now we know. We got a good question from Michael Williams. I think we're going to bring Michael onto the panel. There he is. Fantastic. Michael, come on down.
Hey guys, can you hear me all right?
Yeah, absolutely. Better than me.
Okay. Hey, yeah. So we have a platform that uses.
Oh, we've lost you, Michael.
Must be something to do with Michael, the name.
Everything dropped for a second. Am I back?
Yeah, you're back. Yeah.
Okay, sorry. Yeah, so we are interested in WebRTC game streaming, and we've been having trouble finding, game clients that work through Chrome. So if you don't mind sharing some of those with us, that would be great.
Sure. When you say game clients, what exactly do you mean, Michael?
On the measurement slides, we were talking about using Chrome internals for WebRTC. And yeah. I guess that would work if you had a game client that was using Chromium or Chrome.
Yeah, we can. Why don't we have, we can catch up after this, and we can show you what we know.
Oh, sure. Thank you. That sounds great.
Cool. Thanks, Michael. Great question. On we go.
Thanks, Michael. So yeah, this is a quick demo where we're going to show the software solution that we've developed that can help measure the cloud gaming metrics that I was talking to you about, primarily being input latency, frame rate, and the blockiness, as we called it. So I hope you guys can all see the video. So the first thing that we're doing is to select the game. So in this case, I'm running, let me just pause. The setup is we have a Windows PC that's connected with an external monitor, and typically what we do is we game with an external monitor. So, and then we run the tool on another monitor. So the tool, first we select which app we're trying to profile. It could be Chrome, it could be the Chrome browser, like what my previous Michael was asking, or it could be your another game, a native game. All right, going on, and then we choose what's called which display are we going to actually be looking at for this measurement, because a tool needs to understand which display. And then here you'll see that I'm also selecting an ROI. ROI basically means the region of interest. So the way the input latency currently works is we look at an area around, let's say, the gun muzzle, and we try and understand if there is substantial change for us to detect that it's an animation holding frame. So you select the ROI using a rectangle a lot, and then we go and hit record. And then once you record all the shots that we fire, for instance, to in this game, which I believe is Fortnite, we will measure latency in the background as the firing is happening. So we also need a couple of other configurations that's not highlighted. Was are you using the mouse left click, or are you using the gamepad? So for instance, here we are looking at the mouse as the trigger, and the left mouse button pressed is the mouse and the left button. Those are our main triggers to be able to compute what we call the latency. And this chart here, you can see it's measuring the input latency as we record. Moving on, once we finish the session, we can also tag. We've got some features by which we can tag the session to say, was it a good user experience? What did the user feel? Subjective data, what game did I play? And then what platform did we use? Did we use NVIDIA, GeForce, or whatnot? And after that, all the data gets uploaded to our web dashboard. And here you can see the same session that my colleague did, and all the metrics that were collected are all available in the web dashboard. It can be exported as a CSV, or it can be exported using one of our APIs that can be used. So here you can see the latency that we just measured on the web dashboard again, and with some statistics as well. On the right hand side, you can see the median, all the rest of the statistics scrub through, and you can find out what was happening at different points in time when you were gaming. For instance, I had a high latency here towards the end, and it turns out it was a reload. So that was just a quick demonstration of what.
Okay, a couple of questions from questions on Pronet from Yang Liu. There you are, Yang. Come on down. Please ask your question. Good to have you here.
Hello, Tausig. So my quick question is this software currently mainly for PC, or can it also run on mobile?
It can run on mobile as well. What we're showing it is on PC. We've got support for it in Android as well.
I see. Thank you.
We have another question from Osman Bali, who's been guiding me carefully through my sound issues earlier on, so we have to bring him in. Osman?
Hi, Osman. Pleased to meet you again, mate.
Hey, hi, Karthik. Hi, Michael. How you all doing?
Thanks, brother.
Yeah. So beautiful, profiling and, insight into this new tool. What I wanted to ask is, might be outside the scope of your tool. While we're measuring latencies, you taking the gunshots and measuring the latency, the visual aspect from the time you click till the gun fires and you see the gunfire. What I wanted to know is, can you correlate like those metrics to the sound? So to ensure that you click your button, there's no latency, you get the sound at the correct time, and you see that gunshot at the same time.
Yeah, you're basically talking audio latency, right, Usman?
Yeah.
If I read.
Yeah.
Yeah, that is something that we've actually done as well. We haven't brought it into this, but yeah, certainly that's something that we can do, but not in this particular soft demo that I showed.
Okay, hopefully we can do a case study on our products.
Yeah, with audio, the only thing I'll be honest here. Audio, the only thing that's generally an issue is if there's a lot of background sound. Typically, what we have to do is if it's a gunshot, you have to find a location in the game where you're reasonably quiet to be able to understand what the latency is. If you were to go and in a proper game and you're with other people, then it gets it's a little bit more tricky. That's the only thing we found it to be an issue. But with input latency, we've seen that the software method works even if you're playing along as normal. Let's say you're in a battle and you're actually playing it, you can find what the input latency is.
Sure. Thank you for that input.
Yes, Osman.
Thanks, Jan. Thanks, Osman, for those questions. We have another question from the prolific Michael Williams here, but I think we'd better move on for now. Michael will come back to you. Also, the ProNet fact sheet has just been put into the chat, everybody, or a link to it. So if you're interested, follow the link that Adele's just put up there and you can download the fact sheet. On we go.
Perfect. Thanks, Michael. So now that we've seen what are the metrics, how do they translate? The key question is, how do these metrics translate to gamer experience? Is it good? Is it bad? Right. One of the key questions that we get is, what are your input what are your input latency values? What is good for a frame rate? What is good for input latency? What is good for a battery? What is good for a resolution? Right. So we'll touch upon some of those topics that I think are important to be able to convert some of these metrics into actual gamer experience. So here within GameBench Labs, what we do is based on our research, we've come up with what we think are good values, what we think are a band of values that for instance, if I were to hit a consistent input latency, this is not our round trip time, bear in mind, this is not the network round trip time. What we have here is the end-to-end user input and response animation, right? So if the time between user input and response is less than 66, that's almost, it's almost like an esports gamer kind of latency that we're talking about. Between that and let's say 66 to about 83 is what we would call as a great latency. And if I were between 83 to 133 milliseconds, that is what we would call good, basic, and you can read the rest of this stuff. If it is anything more than 167, it is poor. And what we are interested in is understanding not just one value. We're interested in understanding how tight your experience has been, right? So if we were to collect a number of input latency samples, you want to understand what is the percentage of my experience. So if I had 100% of my experience within the good band, that is a consistent experience, both from consistency point of view and the overall median latency is also in that good range. So that's what we want to target. That's what we're looking for when we take a cloud game and we are trying to assess, is it good or not? That we take all the samples that we've collected, and then we try and band them up as you can see in this nice little histogram that we plotted. You can see the light blue corresponds to the good, and the pink corresponds to the basic, and the red corresponds to the poor. And to visualize it in a better, here you can see that 22% of my gaming session was in that good, 38% was in that basic, and 41% was poor. So overall, this wasn't a great experience, right? So this is what we take the metrics and we're converting it to what the gamer would have noticed in an objective manner. And what do networks need to do to be able to see how you want to push that distribution to be tighter, and you want to push it to the left. So once you push it to the left and it's tighter, that's when you're providing the best experience for your cloud gaming experience. The next aspect, so the key thing that I also need to highlight there is this is what we call, comes under the banner of responsiveness, because it categorizes how responsive your experience is going to be from input to action. The other frame rate, as we call it, falls into the visual fluidity category, right? How fluid my experience is. How fluid my experience is dependent upon how many frames am I able to render on my client. And even for this, we've got, based on our experience, we've come up with some thresholds and criteria that accurately kind of capture the user experience and whether it's good or not, whether it's good or in that basic category. So for instance, here, if you see game A, when we played it on Galaxy S20, we're seeing that it's able to achieve 100% in that band what we call a 60 FPS band, it's a great experience because my median frame rate was above 58 and my minimum frame rate was between 54, at least great. It wasn't lower than 54. And what we call the frame rate variability was less than 2. That's basically a measure of how between second to second is my frame rate jumping all over the place. You don't, for a consistent experience, you want it to have less variability as possible, and less than 2 is what we consider as a great experience. So this is a good way of capturing and comparing 2, 3. If you have a lot of samples, it's a great way to compare. Was your frame rate experience good or bad? And this is probably not that relevant to ISPs, which is the topic of this webinar, but battery which is very useful and very important metric for laptops and mobile devices that are not plugged to the wall. We've seen that you want to be able to hit that 5 to 7 hours for that decent experience. Anything less than 3 hours is quite a poor experience, and if it's greater than 10, it's a smashing experience. So some of these we tested a few different games, and you can see the thresholds here. In particular, that one device, for instance, the iPhone 6s, which is a older device, it's not able to cope with a decent battery life. In all the tests that we did, it was less than 3 hours. So it gives a quick indication of what you should be striving for if it's a mobile device where battery usage is important. Now, coming to an important topic that I think we should address. So we've been speaking about game experience. As network vendors, there is two aspects. There is one which is gaming experience metrics, then network metrics. Right? We want to be able to relate my input latency to what is the round trip time. For instance, as network engineers, you try and understand what is the round trip time, what is the packet loss, what is the jitter. We can't design networks generally looking at other aspects. Obviously, the gamer is not seeing a round trip time or a jitter or packet loss. Gamer is seeing the input latency. That's what they're seeing. But that's what we want to measure. But to measure that, is ping ping enough? Because that is something that is worth going ahead here, discussing a little bit. So for this, it's worth highlighting what does input latency look like and what is the breakdown. So here you can see that the input here is, we put a controller. The input from the controller has to reach the operating system. The operating system gives it to the client. The client has to send it through the uplink, to the game server. So that's where the actual game is rendering. From there on, it goes back into the downlink. Once the game is, once the animation frame has been processed, it needs to encode that, send it through the network again. The client device has to receive it. Now, when it receives it, there is some issues with respect to how it receives it, whether it receives it in order, out of order. It has to build the whole frame before it actually sends it to the decode pipeline. Once it's decoded, then it has to send to your GPU pipeline. Then it has to go and display it. So as you can see, there's multiple areas for where, so it's not just network is a part, it is a variable part, but it's not the only part in this cloud gaming experience. And as you can see on the right-hand side, they are some of the indicative numbers that we've written down. So peripheral latency, in the case of Windows, is between 1 and 4. But what we found some cases where in mobile, for instance, in Android, your peripheral latency could be 100 milliseconds. So in case you're not using the right firmware on your controller, it can ratchet up quite a lot. So there is a variable there as well. So if, as a customer, you're trying to ask what you want to provide, you want to understand what input they're providing, what input device they're using, for instance. Then the input capture, as I mentioned, is how long does it take for that to be registered on the operating system. Uplink is up, as I mentioned, how much time it's taking for that data to be streamed to the server. Native game latency, that's how much time the server is taking to actually render out the output frame. That's usually between 32 to 98. Then you've got the video encode, which is quite small, downlink. the frame packet buffer, which is quite important because once packets come back from the video from the game server, they are out of, usually there's a buffer on the client which takes all the packets, and even if they're out of order, it has to wait for a frame to be frames worth of data, and then it has to reconstruct that frame to be able to display. And then it has to send it to the video decode, and then comes the display latency. So it's very hard to, it's very hard to take this and summarize it with just one number, which is a ping. So that's basically where I'm trying to get to. So there are some other issues we've seen with ping, which is in some cases, we've seen that ping or ICMP packets are deprioritized. All real-time traffic that we've seen is generally not that nature. It's all UDP based. They are generally treated differently. We've seen UDP, in our engagement, we've seen that they are treated very differently. The ICMP is blocked by some servers. Typically, to measure networks, people use just a ping to a data center. In those cases, you will not catch any peering issues that are actually happening for the actual gamer, right? So we've seen in some examples, gamers playing a popular game from two different locations, having the same ping but completely different experience. That's because peering arrangements were not set, between two networks. So it's interesting that that's not going to catch those kind of issues as well. So the correlation in general, what we've seen between a ping type approach to what we call is a real gamer perceived latency approach is probably low to moderate, and we've highlighted it, something that we've seen in one of the studies here. You can see that there is there's probably no correlation here. For instance, on the right hand side, you can see that this blue operator had lower ping, but they had higher input latency, and same with the other two as well. So it's very difficult to be able to say that correlate ping to user perceived latency. So now moving on, I'd like to look at some of the data that we collected from the UK ISPs. Bear in mind, this was done for analysis purposes only, and we've applied our methodology, the gaming metrics that we've been talking about here: input latency, frame rate, image quality, things like that, collected using our tool. But for a sample set, we've taken a few different operators, we've taken some data points from there. So it has to be used only for, it has to be seen from that lens of analysis purposes, right? So going into the test details, what we did were, we used Stadia as the platform, and we chose Destiny 2. Within Destiny 2, we went into what's called the Cosmodrome. We did multiple 15 to 30 minute gaming sessions. So we had a bunch of people, 8 to 10 people, performing 15 to 30 minute gaming sessions using our software method, which the ProNet is a tool that we call ProNet Windows. We collected thousands of data points. And fundamentally, we're looking at two aspects here. What is the input latency? What is the frame rate? And on the ISPs, we checked BT, Virgin, and TalkTalk. And those are the plans that some of our testers were on: BT Full Fiber 100, BT Fiber Essential for BT, and then we used the Virgin 200, Virgin Cable 100, and then for TalkTalk we used Fiber 150. So that was the test scenario, the testing we did. Now going into the actual values. So here on this particular graph, what you can see is the raw values for input latency. So here straight away, what we want to see is a tighter band, and the spikes, ignore because the spikes were for reload. If you ignore the spikes on all of these graphs, what you want to see is lower on this graph and tighter. So as you can see straight away, that from the data that we collected, it looked like that TalkTalk provided the lowest median latency and the tightest grouping of latency values. So this is important from a consistency point of view. As I mentioned earlier, you want to be able to hit lower input latency value, but at the same time, you also want to make sure that the deviation in all your samples is as low as possible. So when it came to the other two operators, they were still quite tight. I think what we need to say is the general experience was still okay, but the spread of values was probably higher. Another way to visualize this is the histogram that I showed earlier on. So if you looked at the three operators here, you can see that, especially when we did BT, we saw that 65% of the samples were in that good range. And we got like 35% of the samples were in that poor or basic range. Whereas something like TalkTalk, you found that most of the data was, 99% of the data was in that good range. So it provided a more consistent experience. The Virgin was sitting somewhere in the middle. Moving on to frame rate, what we observed was kind of the similar pattern as well. So here you can see down that we've grouped 57 to 60 FPS as dark blue, and then 31 to 56 is the light blue. So you want dark blue as much as possible, which is again what we saw with TalkTalk, but BT and Virgin had slightly different results, with BT having 57% in that light blue range. But basically, these two metrics kind of capture how well your gaming experience is perceived by the gamer. We did one more experiment. As part of the tool, we also collect we collect ping to the game server. So we are able to take the identify dynamically what the game server is, and then measure what the ping is. So we run a ping exactly at the same time as when we measure input latency. So if I'm having my input, if I'm pressing my mouse now, we also send off a ping request at the exact same time. So what you can see here is the correlation. We plotted ping on the x-axis, and we plotted input latency as we've observed on the y-axis, right? So you can see straight away that the trend line that we can see is not, there is some correlation, low to moderate correlation maybe. Usually for a very tight correlation, you want this R-square number, the correlation coefficient as it's called, to be more than 0.7. If it's more than 0.7, you can replace one with the other. So what we've seen is low to moderate. So you can use ping maybe, but it has to really be augmented with if you want accurate gamer prediction, you need to actually use what the gamer is actually seeing as. So that was the last deck on ping. I'm coming close to the end.
Okay, there's a couple of questions, maybe Kay, if you're up for that.
Yeah.
In particular, our good friend Dragos Florentin of Product Madness, senior QA guy at Product Madness, has made a number of really good points in the chat, and just going to bring him into the panel. Dragos, speak to us.
Sure, thank you, Michael. Just a question on the latency. I was thinking, if you, as a gamer, you use a gaming monitor which has let's say 240 hertz and a 1 millisecond response time, and usually these kind of monitors, they have a way where you can connect your mouse and your keyboard to it, so that the latency on these devices are kept to a minimum. I was just wondering, is there any difference in data between this kind of setup and, let's say, a normal setup where you have a monitor of 60 hertz and your keyboard and mouse are connected through your PC, not your monitor?
Sure. So that's a very good question, Dragos. When it comes to peripheral latency or the display latency, what you said applies to those aspects of latency. As you can see, they're not very high in the overall spectrum. So the overall spectrum for cloud gaming, you're looking at 90 to 100 milliseconds is what we're finding in the ISPs in the UK, right? 90 to maybe 110 milliseconds latency. So within that, the amount of the gain that you're going to get for using a gaming mice as opposed to a gaming monitor or a normal mice or a normal monitor as opposed to a display, a high frequency monitor is not much. You have to also remember that some of these streams are just sent at 60. So unlike native gaming, where you can ratchet it up to 300 FPS, and you'd see the benefit of your gaming monitor right there. These streams are still coming at 60 FPS. The providers themselves are coming up to 120, 140 FPS. In which case, yes, your display, your high refresh rate monitor will be useful. But in the scheme of things, for Windows especially, we have only a few milliseconds that we've seen, where you can gain maybe 3 to 5 milliseconds. You could, there are other areas that contribute more. For instance, the native game server, for instance, that contributes 32 to 98 milliseconds, or the downlink, for instance, right, 8 to 20. So that's basically what I'm trying to say. It for sure makes a big difference for native gaming. With cloud gaming, the way it stands now, not so much.
And on native gaming, if I may ask, do you take into consideration G-Sync modules at all? Or doesn't matter in your calculations?
No, that is something that we don't take into consideration.
Okay, thank you.
Thanks, Dragos. Great. Okay, got a question from Marco Silva. He's on the phone, so didn't want to come in live, but wanted to just ask about OpenReach. Did we test if the results gathered on BT translate to all other providers using OpenReach?
No, we haven't tested. These were, as I said, we had four of our testers on BT on different plans. So we haven't tested on any other operators that use OpenReach, no.
Yeah, of course. Yeah, of course. Also, a question from Cam Lilly. Cam, I don't know if you want to come in, or would you like us to ask the question for you? It's in the chat. No, nothing. Okay. Yeah. Oh, there you are.
Oh.
Hi, Cam.
Hey, how are you?
Good.
So real quick, when you're doing the comparisons between the wireless operators, how did you measure the RF performance? So, did you have a minimum threshold of coverage that you were using for these tests?
Wireless, Cam, what were you saying? These are all ISPs.
These are all ISPs. Okay. I'm sorry. I thought you'd mentioned that you were doing something over the air. I apologize. Okay.
Yeah, that is the next part. Actually, we are going to be doing some
Okay, yeah.
data collection and a webinar on mobile operators, because we have some software tooling for Android, as a lady just asked earlier on. But that's the next.
Okay, forgive me. I thought those operators were wireless. I'm in the US, so those are I thought they were wireless operators. Forgive my ignorance.
Yeah. No, they are ISPs.
Thanks for the question. We've got another point from Yang Liu. Yang, can you join again? There you are. Okay, let's try and get Yang back for her question.
Hi, hello, Catherine.
Hi, Yang. Hi, Yang.
I'm from Samsung, so I'm more interested. And this technique, the software you shared for this latency capture is very interesting. But because I'm from Samsung, so I'm more interested in for native gaming. Will this kind of capture technique for the latency be different, or it's similar in terms of the technology?
Well, for native gaming also, it is the same. We measure internally. It's just an app, for instance. So we measure it on Stadia. So Stadia is really an app. But the way we measure inputs is we take software. We take the inputs directly from Android, lower level, and we take that and match it with the video. Video capture so we're capturing video and we're capturing the input events, and then we use both of that sources of information to capture latency. So yes, it will work for other types of native games as well.
Is it some software you are still in developing for the native gaming, or it is?
Yeah, this is
Right.
still something we're developing. Yeah.
Okay, thank you. Yeah.
Yeah, what we can do, Yang, is maybe get in touch later on and
Yeah.
talk about it a little bit more.
Okay. Yeah. Thank you.
Thanks, Jan. I think we've got time for one more question. Walter Suto is on the panel. Still muted. Okay, sorry, Walter. Seems like we can't get sound from your side, so my apologies. But what I'll do, if I may, is read the question for you. In cloud gaming, do we have better latency performance using encoding on GPU than encoding in CPU in large servers?
Encoding in the CPU, yeah.
Yeah, it's in the chat. Okay, if you want to have a glance at it, right at the bottom.
Yeah. Okay, cool. I'm just reading it. In cloud gaming, do you have a better latency performance using encoding? Okay, so this is something that this depends really on the platform vendor. We measure what the user sees. So it is likely that Stadia, this is a question more for if we don't have the capability to switch this encoding from GPU to CPU, this is predefined by NVIDIA or by Stadia or by xCloud. So we use whatever method they're using. So, and we don't have any information benchmarking it on CPU versus GPU, fortunately.
Thanks, Kay. That's great. Do we have time for one more question? We got 3 minutes. We got Sean.
Yeah.
Sean Yardley. Okay, let's do it. Sean, there you are. Come on in.
Hi, Sean.
Okay, Sean, you're on if you want.
Mic issues.
Sean's having mic.
Okay, let me read. Sean's question. How do you detect the action has been performed after an input? Is it manual correlation with a particular frame? Happy to discuss if you run out of time. So I'll quickly go back to the video. So basically, what happens here is the software. Let me go back. So we measure something, if in case you missed out. So we draw something known as the region of interest. So first we select the app, then we select the display, and then this section is where probably the answer to your question is. We select what's called the region of interest. Basically, it's talking about where is it likely are we going to see a noticeable change in animation, in pixels, or in things becoming brighter. Luminosity is what we use. So once we draw the region of interest, we check with the threshold, whether you can see on the top here. So here we check if more than 25% of that region of interest changes, then we stamp it as an animation frame. So now we have the timestamp for when the input was pressed, and then we also have the we also have the frame in which that the threshold was met. So we use that to compute latency. Hope that answered your question.
That's great. Sean's happy, and we've got a question from Michael, but we are out of time. Michael, if we can pick that up after the event, we are right on the hour right now. So let's by all means connect on. I think you had 2 questions that you wanted to ask. Apologies for not getting to all of them, but I know that you did ask a question earlier on. Okay, shall we move towards wrap up?
Yeah. Just to wrap up, I think it's worth just highlighting what we're going to do. One of the things that we're going to come up is we're going to also look at native gaming. I know we looked at cloud gaming, which is one area that we've looked at, but native gaming is an equally important area of focus, and we need to understand what the user experience is going to look like. So that is something that we'll run a couple of webinars on. We're also going to be repeating the same kind of experiments on when using a mobile operators. Does actually 5G have an impact? If so, what is it? What is the impact on latencies that we're observing? We're also going to be doing some tests on other geographies. We're going to be looking at a few European countries, some Asian countries as well in the series of webinars. Yeah, that's all. Hopefully, if you guys have any questions, happy to answer later on. Just send us our questions, and we'd be happy to answer them.
Okay, thank you so much, and thanks everybody. That brings us to the end of today's session. Thank you for sitting in with us and for your great questions, and thanks to Kay for running a great presentation. As you know, you'll all be shortly receiving your copies of our UK performance report, and we're also going to attach the fact sheets for our ProNet and Labs offerings, so you have the full picture, and a recording of the event will be shared with you all and available shortly on our website. As Kay said, our next Performance IQ Network Performance webinar will be on the Western European market, and we'll also, on a slightly other subject, we'll be running a joint session with some of our key partners on automation and scaling of game performance testing. So for all that, keep an eye on your inboxes. Thank you again for joining us, and we look forward to seeing you very soon.
Thank you. Thanks, everyone.